Welcome to this tutorial that provides a conceptual description of computer adaptive tests, or CATs. I will review how CATs work and when they can be useful. A computer adaptive test, or CAT, is a type of measure in which the questions a person answers are tailored to that person. Each response is used to further refine a person's score. Unlike a fixed-length short form where everyone answers the same questions, CATs administer different questions to different respondents. All CATs begin with an item bank. An item bank is a collection of items or questions that are all assessing a concept. For example, in an educational setting, you can have a CAT assess vocabulary. In a clinical trial, you can have a CAT assess level of fatigue. These concepts or domains need to be able to be ranked on a continuum from low to high. Let's use physical function as an example. You can think about people's level of physical function on a range from being bedbound to being able to participate in a competitive sport. Through psychometric testing, measurement scientists can rank individual items along this continuum. This is called calibration. Each item distinguishes people at a certain level of physical function. For example, here an item might ask about level of difficulty walking a short distance, and here an item might ask about one's ability to climb multiple flights of stairs. A CAT often starts with an item in the middle of the range. After a person responds, a score is estimated based upon what we know about where that item falls along this continuum and the specific response provided. A number of different psychometric models exist that may take into account other information, but I won't cover those here. In this case, the respondent is a rather fit person who plays soccer recreationally. After her response to this first item, the CAT algorithm estimates her score and then finds an item in the item bank that does a good job at distinguishing people in this higher range of physical function. After the second response, her estimated score is updated and the CAT algorithm selects another item tailored to this level of physical function. Now imagine a different person answering that same first item from the CAT. In this case, this person has a much lower level of physical function. The CAT algorithm estimates his score in this lower range, then administers an item that measures this level of function well. The respondent continues answering items until the CAT ends. Because all the items are part of the same calibrated item bank, the scores between individuals can be compared even if they didn't answer the same questions. Both people have answered a very small number of items, but have a very precise score, that is, a score with a very small standard error of measurement, as shown here with the gray band. With each item that is administered, the error of measurement gets smaller and smaller. The stopping rule for CATs can be the number of items. For example, CATs in the Patient-Reported Outcomes Measurement Information System, or PROMIS, usually require a minimum of 4 items to be administered and force the CAT to stop after 12 items. You can also stop a CAT when the precision of a score, defined as the size of the error term, reaches a specific threshold. So why use CATs? First, they offer great efficiency in assessment. The number of questions a respondent needs to answer is minimized, and the precision of that score is high. Second, because CATs are so short, they can be administered in situations where there's very little time, like in a clinic visit. Or you can measure more domains in the available time because each CAT is so brief. CATs don't have a problem that you see with fixed-length static short forms. In a short form, the range of what can be measured is fixed, and there is a limited amount of precision. On the left is an example of one short form that covers a wide range of physical function, but is only able to provide a gross estimate, represented by having few tick marks. On the right is a different short form that can offer a very precise estimate of physical function, but only in a very narrow range. For these reasons, CATs have been commonly used for licensure, certification, college entrance testing, personnel testing, educational assessment, and more recently in patient-reported outcomes, things like pain, emotional distress, physical function, and fatigue. Patient-reported outcome CATs are used for a number of purposes, including clinical research, clinical practice, or in evaluating quality of healthcare. If you would like to learn more, I recommend trying out a demonstration cat at www.assessmentcenter.net. If you want to learn more about cats and item response theory, the statistical model used to construct them, watch Karen Cook's 6-part video series. You can find those by searching for Karen with an O, F. Cook on YouTube. Finally, the healthmeasures.net website provides much more information about patient-reported outcome cats. Thank you for watching this tutorial. Support was provided by a grant from the National Center on Advancing Translational Sciences at the NIH. Many thanks to Karen Cook for her generous donation of slides. Thanks.